Good evening, everybody. My name is Pat Murphy. To all our international guests, bonjour, ciao, hola. You're welcome to the Irish Live Beef Carbon Farmers webinar. And at this point, would like to point out that there is interpretation, and I would like to thank at this stage all the interpreters for the work that they're going to do over the next hour and a half to help us have a really good webinar. I will just ask, maybe in order of French, Italian, and Spanish, the coordinators just to make sure that everybody is using the interpretation service. So Jocelyn, if you might start just in French, just say to people about the interpretation.
Bonjour à tous. Donc, pour la traduction, vous avez dans le bandeau de Zoom, vous avez le channel, disons, pour choisir la langue que vous voulez. C'est en bas à droite.
The language that you wish.
Et il faut choisir donc dans le menu déroulant français.
Okay, Sarah.
So if you are hearing me, hearing me in English, it's not appropriate. You have to click. Il faut appuyer bien sur la langue français.
Sophie in Italian, if you're there.
Merci à vous.
Buon pomeriggio a tutti. Per scegliere la lingua italiana dovete cliccare sul tasto interpretazione e selezionare italiano e avete la traduzione in italiano.
And Paula in Spanish.
Buenas tardes, va a empezar ya la jornada. Para poder escuchar en español tenéis que hacer clic en el botón de abajo que pone interpretación y seleccionar el canal español. Si me estáis escuchando en inglés es que no estáis en el canal adecuado. Gracias.
Thank you, everybody. Okay, so without further ado, we have a very busy schedule. I'll introduce our first speaker. Jocelyn Andorand is the European coordinator of the project and with the French Livestock Institute, and he will speak to us on shrinking carbon footprint without compromising beef production. So take it away, Jocelyn. Thank you.
Thanks a lot, Pat. I hope you can see my screen. So today we are presenting a webinar with all the great work that is carried out in Ireland in order to reduce the beef carbon footprint. We initiate the live beef carbon with 4 countries. In the beginning, it was foreseen to be visits on farm, so on-farm visit in Ireland. But you understand that with the COVID situation, we are vastly sorry, but we have to do it by webinar. So I want to thank again Donald and Pat to organize this webinar. So first of all, I wanted to show you that the beef production in Western Europe, it's quite carbon efficient. So this is 2013's figure, and here you will have the higher the bar is, the higher your emission per kilo of meat is. And Western Europe is quite efficient in comparison to the world average, for example, and in comparison to Latin America or, for example, that is here. So it was just to remove the stress. We are in a way that we are already quite carbon efficient, but the idea was in order to counter the global warming, we have to do our share as well, and we have to reduce again our carbon footprints, even if we are already quite efficient. So the live beef carbon has been launched 5 years ago now with 4 countries involving 2,000 farmers. So thanks for all those farmers that are involved in the project and that carried great job, and also all the technicians, because it's more than 50 partners. So it was quite challenging in order to manage all these assessments. And we conduct more than 2,000 assessments on farm. And the idea was to reduce the beef carbon footprints by 15% in 10 years. So we'll see during my presentation how it is achievable without cutting the number of animals, for example. So this is quite an example of greenhouse gas assessment on farm. So the main input data are animal census, the number of animal, of course, the slurry produced, the fertilizer, and so on. And it is presented like this with a net carbon footprint. The arrow is the value of the very farm, and this is the reference for the same system. And after, we can have emission minus carbon sequestration equals the net carbon footprint. So that was the idea of the project. And so to have a first assessment that produce those results, this is the emission distribution of the 2,000 demonstrative farms we assessed. And you can visualize that more of 50% of the emissions are linked to enteric fermentation. So the more you have animal, the more enteric fermentation will be important. And the idea, so as you can see, all the unproductive animals are playing a are having a huge impact on the carbon footprints, the overall carbon footprints of the farm. And the second source will be manure management, and after feed and straw purchase, fertilization, the energy, and the fertilizer manufacture. So once we have this picture, the idea was what is the viability between the different farms. And on this figure, you can see it's the greenhouse gas emissions are represented here. So the higher you are, the point here are of course emitting more than the farms that are here. So there is 450 farms in this picture, and 25% of the farm are situated here, 25 here, 25% here, and 25% here. And what we can see, it's a suckler to weanling system only. So 450 farms from suckler to weanling system. And we can see that there's a huge variability because we go from 9 kilo of equivalent CO2 per kilo of live weight to 27 kilo of equivalent CO2 per kilo of live weight. So the idea was this huge variability between the greenhouse gas emission within the same system reflects a huge variability of technical performance. And the idea was the 15% that we want to cut, want to reduce, the objective of the beef carbon project, we think we can achieve this objective without changing our system, just optimizing our technical performance. So this is just another figure in order to show you that this is a different mitigation technique. For example, there is fertilization to control appropriate fertilization, the energy saving, the grassland management, methanization here, and additives, for example, and so on. So here, what we can see in this figure, it's what is under the bar is a win-win situation, is economically interesting for the farmer. And here, it's costly for the farmer. So we emphasize on these win-win mitigation techniques that can lead to -10 to -25% of beef carbon emission on the very farm. So we think that those mitigation techniques are win-win for the farmer, and we tried to disseminate them among technicians and farmers as well. So the main conclusion I have on this very short presentation is there is a margin for improvement in technical efficiency and productivity with a win-win situation between environment and economic results. So there is a margin for improvement in the farms we assessed, And there is a high variability of mitigation potential depending on system type and system optimization. Of course, if your farm is really, really good, there is almost no unproductive animal, you will have difficulty to reduce. But it means that you have already a very good carbon footprint. So maybe it's enough as well. And maybe you can play on other mitigation potential, such as carbon sequestration, for example, through hedgerows implementation or grassland management and so on. And the possibilities to reduce greenhouse gas emission without reducing beef production exists. So this is the current work with farmers and the beef chain in the 4 countries where we have carbon national action plan that are conducted right now. So just in order to maybe to project in tomorrow, how to so the idea in this project was to have a greenhouse gas assessment, to build a carbon action plan with the farmer, of course, and to identify mitigation technique to implement on farm. And after, to have a final assessment to quantify the non-emitted tons of CO2 equivalent. And now I think the challenge for us it's to build something in order to reward farmers for those non-emitted tons of CO2. And like this, we can really involve more and more farmers in reducing their greenhouse gas emission. So we can work through eco scheme in some countries, through agro-environmental measures, through premium and prices maybe, and also in France we are working also on carbon credits, and I hope we can of course share all together to work on all the way to reward farmer for carbon efficiency. So thank you very much, and I hope you will have plenty of questions in order to answer you.
Thank you. Thank you very much, Jocelyn. Much appreciated and right on time. Just one thing just to remind you of, we have within the system questions and answers. And if you want to put a question, we will, after the first 4 presentations, we will have a bit of time to put some questions to the presenters in a panel session. So if you want to put your question, just do so in your own language in the question and answer session. And some of my colleagues will help me with the translation of that to put the questions to the speakers. So our next speaker then is Donal O'Brien. Donal is a farms systems researcher with Teagasc here in Ireland, and he'll be talking on Irish beef farming rising to the climate change challenge. So Donal, if you want to share your presentation and take the floor.
Yeah, Pat, thank you. So I'll just, I suppose, give you an overview of beef farming in Ireland for those of you not from Ireland, and outline how the sector is responding to the climate change challenge. So I guess just some background. Ireland, the Emerald Isle, is about 84,000 square kilometers, and it's primarily covered in grassland. So about 62.5% of the total land area of Ireland is in pasture, which is about 90% of our agricultural area, and is the highest proportion in Europe. Beef farming in Ireland is largely grass-based, as you'd expect with our temperate climate. So we have cool summers, mild winters, and plenty of rainfall. And that's conducive to a very long grass growing season. So you can see here on the map on the right, our grazing season can be over 300 days in some parts of the country, in the south and west, and a bit less than that in the north and the east. So this gives us, I suppose, our producers a very nutritious and cost-effective source of feed. So looking at the the number of animal or beef animal or cattle in Ireland, we have approximately 6.5 million cattle in Ireland. So since Ireland joined the European Union, the total cattle population has hovered between 6 million and 7 million animals. The beef cow population increased considerably, I suppose, in the mid to late 80s after the abolition of the milk quota system in 1984. So in the mid 80s or before, it was around 400 to 500,000 cattle or beef cows, and it increased to 1 million cows in the 2000s before the population started to decline again. So the dairy cow population decreased in the 90s then during the quota system, and then it has started to increase again recently since the abolition of the quota system. So we have about 1.4 million cows or more dairy cows and about 920,000 suckler beef cows. So this is a map of the distribution of suckler beef cows in Ireland from the Irish Cattle Breeding Federation, and it shows that the greatest concentration of beef cows in Ireland is in the west and the border region. So counties like Mayo and Mayo and Galway would have a large number of suckler cows. West of the Shannon, beef cows would represent 63% of the total cow herd in the border region, 79% in the west, and 54% in the Midland region. When we look at the farms that we sampled in live beef carbon, the demonstrative farms, part of the National Farm Survey, the picture is similar. So the red dots are cattle rearing or suckling operations, and there's more of them generally towards the west and border regions. And the blue color dots then are more fattening and finishing type systems, where they're more common in the east, maybe south, where there is more arable type land as well. So beef farming in Ireland, it's a very, very common industry. So over 75% of farmers stock beef cattle. So that's out of 133,000 farms. We have 75% with beef animals. There's a mixture of part-time and full-time operators. So around 40% of our producers are part-time, have an off-farm source of income. And that has been growing gradually in the last couple of decades. The main production systems that they operate, broadly speaking, are suckler to beef and dairy calf to beef. So suckler to beef systems, calves would suckle for 6 to 8 months, and the main, I suppose, breeds that are used in the suckler beef herd are late maturing continental type sires, so Limousin and Charlies. In the dairy to beef systems, it's more Frisian type cows. So the surplus calves from the Frisian cows are reared for meat production. They're usually sired with early maturing breeds like Herefords and Angus, and they're a growing share of the beef production in Ireland as the dairy sector has expanded in recent years. So since, I suppose, 2012, the production of beef in Ireland has increased steadily. We're very much an export-focused sector. So our self-sufficiency in beef production in 2019 was 680%. So we have to export majority of our beef. Over 90% of it is sold abroad. Half of it, or approximately half of it, goes to the UK market. The overall value of the beef exports was about 2.5 billion, I think, in the most recent years, and has been steadily increasing over time, as you can see in the charts. The beef carcass output has stayed around between 500 and 600,000 tons of carcass per year. I suppose it's important to point out that the sector is reliant on supports for especially for smaller farmers. So I think only 30% of the cattle enterprises in the National Farm Survey are considered viable, so they need supports. But this support has a multiplier effect in the rural economy, and it generates a lot of other economic activity that helps, that more than pays for itself. So then just moving on to the actual greenhouse gas emissions. So as Jocelyn was outlining there earlier on, cattle production, like all activities, generates greenhouse gas emissions. The main greenhouse gases emitted by beef farming systems are methane, nitrous oxide, and carbon dioxide. The warming potential of these different gases is expressed in terms of carbon dioxide. And the current atmospheric science indicates that methane and nitrous oxide have a much greater warming effect than carbon dioxide. I suppose, unlike most European countries, agriculture is a major source of greenhouse gas emissions in Ireland. So the chart on the right, just looking at agriculture, makes up 33% of our emissions typically. So I think the average for the EU is around 10%. The new climate change bill that we have in Ireland is aiming to reduce greenhouse gas emissions or carbon emissions by 7% per year, and put Ireland on a trajectory towards net zero emissions or climate neutrality. And agriculture is expected to reduce its emissions by 10% between 2020 and 2030. So cattle farming or beef farming has been responding to the climate challenge by reducing its carbon intensity. So these charts are from the National Farm Survey's latest sustainability report. It shows the carbon emission per kilo of beef live weight, and it's been gradually improving since 2012 when the survey began recording this information. And as I suppose a combination of improvements in productivity and efficiency. And it's also showing that the top performing farms tend to be the most efficient and have the lowest carbon footprint or carbon intensity. However, I suppose when we look at it per hectare or the total emissions from the farm, we can see that the top producing farms tend to have the highest emissions per hectare. And the main reason for this is because they're producing more beef live weight. So as a result, they tend to have more emissions per hectare. I suppose the increase in national beef production over the periods has kind of cancelled out the improvements in beef, in the carbon intensity of beef over that period. So as a result, the total carbon emissions per hectare have remained relatively stable over that period. So the main, I suppose, goal of Life Beef Carbon is to work with beef farmers to develop more cost-effective approaches to reduce carbon emissions from cattle production. So the ones I think we'll hear about now very, very soon are low carbon farming technologies like protected urea, low emission slurry spreading. Increasing carbon sequestration in soils is one we're working towards getting more information on, but I think through maintaining hedgerows and adding trees to hedgerows is an easy way of increasing carbon on the farm, and obviously then to try and accelerate the improvements in technical efficiencies and in productivity that we've been making over time is a key part of the beef carbon plan as well. So with that, I think I'll leave it and hand it back over to you, Pat.
Thanks very much, Donal. And what we'll do is have a quick transition, if that's okay. Again, reminding people to put their questions in the Q&A in whatever language you please, and we'll get them translated. Our next speaker is Andrew Crummy, and Andrew is Technical Director with the Irish Cattle Breeders Federation, ICBF, and he will be talking about Ireland's beef data and genomics program and addressing greenhouse gases and climate change. So Andrew, yeah, we have you sharing there, so if you want to take the floor. Thanks.
Thank you, Pat, and thanks for offering me the opportunity to speak at this conference. I'm going to speak about one of the aspects that Donal has referred to in terms of areas of improvement, and that is in the area of technical efficiency and especially around genetics and genomic improvement. The Irish Beef Data and Genomics Program was established in 2015 as part of a 6-year rural development program with the objective of breeding more profitable, sustainable and carbon efficient cows. In being involved in this program, then farmers are paid a payment of €90 per cow per year to complete key actions that are relevant to the program, such as covering the cost of genotyping, or the cost of data recording, or the cost of replacing their herd with higher genetic merit animals. And all of these costs are seen as costs incurred by farmers in completing the actions of the program. And as a consequence, then the farmers receive these payments for supporting the objectives of the program. There are a total of 24,000 farmers involved in the program in Ireland, covering about 550,000 cows. And to date, we've genotyped over 2.5 million animals as part of the program. The program was funded through the EU Rural Development Program, but has been supplemented with an additional national measure around the weighing of cows and calves. We call it our Beef Environmental Efficiency Pilot, and that was introduced in 2019. Just by way of some background, these are the traits that are important for Irish beef farmers in the context of our replacement index, the different data that we collect on farms and through our industry, and then these individual traits are weighted into an overall index, which helps us then rank the animals into the most profitable and most carbon efficient. And to do that, we have a star system with the top 20% of animals then indicated to be 5 stars. And the reason why we introduced this replacement index, first of all, in 2012, was to address the decline that we had seen in the cow maternal traits. So as an industry, we had focused a lot on growth and output to the detriment of the milk and fertility traits. And this was something we were very keen to improve, because these are the traits that are very much linked to carbon efficiency. And as part of that work, we undertook extensive validation work with Teagasc around the indexes and the direction that the indexes were taking us in. And this is some work on animals born back in 2012 and 2013, undertaken by Dr. Alan Toomey, using data from the national database. So this analysis was based on 92,000 commercial females that were born in 2012 and 2013. And then we were looking at their subsequent performance for the key traits linked to profitable, carbon efficient beef production in the subsequent years of their life. And we can see that compared to the lower genetic merit animals, these high genetic merit animals on farms had shorter calving intervals, they were lighter cows, they survived longer, they produced a heavier weanling with a greater weanling efficiency, with lower calving problems, and with no loss in carcass performance in their progeny. So that very much gave us confidence that we were indeed starting to breed cows that worked on the principle of producing more from less. And that is the key requirement, or the key objective when one thinks of carbon efficiency, to reward those cows that will have greater output but with a lower level of per unit input. And that is for the replacement index, but we have also seen the same trends are relevant then for our terminal traits. The terminal index then identifies the bulls that are going to breed animals that are better weight for gain aid in terms of carcass gain, younger days to slaughter, and with a lower cost in terms of feed intake. So again, give us confidence that the indexes were moving us in the right direction as well. These were just some of the tools then that Irish beef farmers became familiar with as we implemented the scheme. These are the sort of screens that the farmers used to record the data into, if they were booking scales to weigh their cows and calves, or if they were purchasing replacement females, for example, at farmer or livestock marts. The data was available in terms of the genomic status of the animal, the star ranking of the animal, and all of this was very important supporting data to help promote the objectives of the scheme. It should be acknowledged that initially the scheme was met with a lot of concern from farmers, largely because it was a new scheme, EU-funded scheme, where for the first time a payment was being linked to technical efficiency or aspects around the animal itself. And this was a change, and a lot of farmers maybe weren't sure as to, well, where did their herd actually sit or their cows sit with regard to this new way of assessing technical efficiency around carbon and climate. So there was a lot of initial concern around the objectives of the scheme, but thankfully we managed to get over that, and a lot of Irish beef farmers joined the scheme and are now starting to see the real benefits of the scheme from an outcome perspective. And that's perhaps best seen in terms of some of the outcomes that we now, as we look at for example, this is the genetic trend in the Irish beef herd for those replacement traits. And you can see that based on year of first calving, the trend was declining. So each year our heifers, our newborn, our new freshly calved in heifers, new replacement females, were getting, a reducing value in terms of replacement index. So we were losing those important milk and fertility and maternal traits for quite a number of years. But then that started to turn around when we introduced the replacement index in 2012 and really accelerated in the right direction as we introduced the BDGP in 2015. And the real reasons for those changes, as I said, was the ability of the index and the scheme to then drive change, that we're now getting replacement females coming into our suckler beef herd that are now better on female fertility. You can see this trend has turned around, and with more milk. So again, this trend has turned around, and we have been able to do that without any loss really in the progeny carcass traits. And this can be confirmed as we look at our national data. So this is the average performance of steers slaughtered under 30 months of age from our suckler herd. And you can see a confirmation that there has been no loss in the progeny carcass weights. In fact, our steer carcass weights are sitting around 380, 390 kilos, slightly younger aged slaughter, and no loss in carcass conformation. So again, giving us confidence that we can select for these maternal carbon efficiency traits without any loss in slaughter performance. And again, we also see that at a high level, the fertility trends are now also starting to move in the right direction. Fertility is a trait that takes longer time to have an impact through, but certainly we saw in the earlier slides that fertility trend has really just started to turn, and we're certainly very confident that these upward trends in terms of female fertility, calves per cow per year, percentage calved at 2 years of age, and average calving interval are now all moving in the right direction. And again, this is perhaps best seen in this analysis, where we were able to take the herds that are in the BDGP, the 24,000 herds, and a subgroup of those herds are also taking their cattle through to slaughter. So we have actually a carbon footprint for those herds from Bord Bia. And when we look at this data and compare the top 20% of herds, the best herds compared to the average or compared to the bottom, again, it just confirms that the herds that have the higher replacement index have a lighter cow, so are less costly to keep, are producing a heavier weaning, have a better weaning efficiency, have a shorter calving interval, have a higher calves per cow per year, and are more profitable. And this is based on Teagasc profit monitor data, where we are able to assess the profit monitor data from these herds as well. But also crucially, the carbon footprint on these herds is also lower. It's about 78% lower. And this is important in the context of the objectives of the Life Carbon project, where the target talks about a 15% improvement. And this is being achieved. If we look at the rate of gain here, it will take about 8 years for the average herd in Ireland to move from here to here. And to get that, by doing that, you can get a 7 to 8% improvement in carbon footprint. So again, gives us real confidence that genetics has a very important part to play in the whole carbon footprint, carbon improvement story. And then again, this is just another way to look at the data that I showed in the previous graph or the previous tables. We are now directly measuring methane output on animals in our central progeny test system in Tully, in Kildare. And we also, this gives us lots of confidence that yes, indeed, our models predict that these higher genetic merit animals should be more carbon efficient. In fact, the last table showed that that is the case based on carbon footprinting at the herd level. This is based on actually looking at methane yield output at the animal level. And it tells us very clearly that the higher genetic merit animals have lower methane yields per day. Average methane yield is about 250 grams per day, but you can see that the higher genetic merit animals are getting down to 220, 200 grams of methane per day. And again, this gives us confidence that we really, are moving in the right direction, but we want to go faster. So two of the areas that we're currently putting a lot of focus in on now as we think about our next iteration of the Beef Data and Genomics program. One is age at slaughter, and we've done some calculations in Ireland to indicate that every 1 month's reduction in our age at slaughter, and currently it's 26 months for our national cattle herd, is the equivalent to not having to cull, effectively cull, because that is what some people are proposing, 100,000 cows. So this is a very positive proposition that now, working with Teagasc, working with the industry, we're bringing forward to farmers to consider the real benefits of further improvements in carbon efficiency, particularly around this age at slaughter trait. And another area that we're very excited about is the opportunity to accelerate genetic gain further. And one of the areas that we're looking at in doing that is a proposition to DNA every calf in the country. So at the moment, we are covering about 20% of the total calves through our various projects, but we're really keen to up that and looking at pushing that on to full DNA coverage. And look, that offers up lots of opportunities around accelerating gain, but also labor saving for farmers, enhanced traceability, lots of opportunities in this area. So just to finalize and to summarize, we're very positive about what genetics and genomics can offer in terms of the whole climate and carbon opportunities. If we look at the rate of gain that we're now achieving in our suckler beef herd, we're running at about 60% of the equivalent gain in our dairy herd. And that's a massive achievement given, if we think about the challenges in beef with low levels of AI, many breeds, small herd size, profitability, part-time farming. So again, gives us real confidence that with good data, with a new technology such as genomics, that we can really look to accelerate this level of gain further, and in doing so, move that. We talked about that 15% target. You know, we talked about currently we're achieving 7% over 8 years, and that opens up the opportunity, if we can accelerate that gain, to do that in an even shorter time frame. And the areas that we're looking at are more genotyping, you know, looking at 2-year-old calving, looking at carbon auditing of all of the relevant farms, additional knowledge transfer programs. And so this is all part of the current discussions we're having with our Department of Agriculture and our industry around the next iteration of our beef data and genomics program. So thank you, Mr. Chairman.
Thank you very much, Andrew. That was a whirlwind tour of beef breeding in Ireland, and I'm sure there'll be questions there. Again, reminder to put your questions in the question and answer session. Our next speaker is Mark Plunkett, and Mark will be talking to us about reducing nitrogen emissions on grassland farms. And Mark is a soil and plant nutrition specialist with Teagasc. So I see your presentation coming up there, Mark. So whenever you're ready, you can proceed.
Okay, good evening, everybody. This evening, I'm going to speak to you around the whole area of the efficient use of nitrogen. The title of my talk is Reducing Nitrogen Emissions on Grassland Farms. There's a number of technologies there in terms of the MAC curve. But two technologies that I'm going to focus on this evening is protected urea and low emission slurry spreading, as I suppose options for Irish farmers and I suppose farmers across Europe to reduce nitrogen emissions in terms of ammonia and greenhouse gases. So I suppose just maybe firstly to look at maybe the sources of nitrogen that we come across on farm. So again, organic manures. Again, they're a big source of ammonia, and here in Ireland, we're in a transition moving to low emission slurry spreading, as in the trailing shoe and the band spreader. And again, it's the #1 technology on the ammonia front in terms of reducing ammonia emissions, and that feeds into using lower levels of chemical nitrogen on farm. The other source of emissions in terms of greenhouse gases is fertilizers. Again, here in Ireland, we use a lot of nitrate-based fertilizers. We use a lot of calcium ammonium nitrate. And again, it's a major source of nitrous oxide on the soils that we have. Like here in Ireland, we have a very damp climate. We have heavy soils. We have high soil organic matter. And again, when you put a nitrate-based fertilizer into those conditions, you can get nitrous oxide emissions. So currently afoot, we've done a lot of research, and I'll look at some of that research here with you this evening around protected urea. And again, it's the #1 technology in terms of reducing nitrous oxide emissions on farm. So there is a drive or a target there to replace up to 50% of our calcium ammonium nitrate with a protected urea type of fertilizer. So again, I'll go through now protected urea in a little bit more detail. As I said, it's the #1 technology on the greenhouse gas front in terms of from a nitrous oxide emissions point of view. It has the potential to reduce our emissions by up to 30%, you know, a third of the emissions in terms on the nitrous oxide front. So again, like why protected urea? So again, from an ammonia point of view, again, you know, the trial work carried out here in Ireland quite extensively would show that, you know, where we use protected urea, we can reduce ammonia emissions by 78% compared to unprotected urea. On the greenhouse gas front, on the nitrous oxide front then, so again, by switching to protected urea instead of calcium ammonium nitrate, we can reduce emissions by 71%. So in effect, we often talk about this double dividend or this double-sided coin in terms of protected urea. You know, we can reduce ammonia emissions and also we can reduce nitrous oxide emissions. In terms of, you may ask the question, like what is protected urea? So again, number one there, it's urea coated with a urease inhibitor. So again, this is an example here. So again, you know, it'll be a different color depending on the fertilizer supplier or the product range. The big thing is that it reduces nitrogen loss. So it reduces ammonia emissions. So again, this is a graph showing, you know, its impact on ammonia emissions, where you have protected urea in the purple line and unprotected urea in the green line. Again, we are encouraging farmers here in Ireland to apply protected urea all year round. So again, once we kick off fertilizer season in early spring, we start with protected urea, and we can use it right during into the summer period. In terms of cost, it is coming at a lower cost. So again, compared to CAN, it's anywhere between 8 to 10, 11% cheaper. So again, there's a cost savings there in terms of money in the pocket. We can reduce our nitrogen costs by moving to a more efficient form of nitrogen, as in protected urea. And as I was saying there, we aim to replace CAN, calcium ammonium nitrate, and again, up to 50%. Like currently we use about 1 million tons of CAN product between straight CAN and then blended into products, and we're aiming to reduce that by 50% over the next 10 years. You know, in terms of performance then, in terms of growing grass, again, here in Ireland, we can grow, large tonnages of grass. As Dawn was saying there, we've a long growing season. And again, you can see this is, very solid trial work from Johnstown Castle and carried out on a number of sites across a number of soil types here in Ireland. And again, you can see the triangle, urea plus NBPT, that's the urease inhibitor. And again, from a grass production point of view, it is as good, or if not better, than CAN. So again, we can grow as much grass as we have done historically with a CAN-based fertilizer. And then again, that gives farmers, a lot of peace of mind when it comes to making the switch or making the choice to use protected urea. Currently, there is a lot of research going on the grazing front. So again, looking at the 3 different types of nitrogen: CAN, protected urea, and ordinary urea. So again, this work is ongoing for the last 3 years. It's been carried out across all the main enterprises: dairy, beef, and sheep. And again, protected urea, shoulder to shoulder, the performance throughout the year is quite solid. So we've taken it from, I suppose, the research stage, and now it's been rolled out on farm and been tested at our research centres. And you can see from a production point of view, very respectable or very, very similar levels of production. So again, there's no difference between a CAN-based program or a protected urea-based fertilizer program. Just to say as well, here in Ireland, we have 6 main fertilizer companies or blenders or manufacturers here in this country. And again, we have approximately 20 different products now available to Irish farmers. If we take the first company here, we have a straight product, as in the 46% urea plus NBPT and plus NPPT. So this is one of the Limas. It's a urease inhibitor from BASF. We also have then urea plus sulfur, so 38% nitrogen and 7% sulfur. And then we have, again, another treated urea with potash and sulfur in it. So again, they are in the marketplace there, and they are available to farmers in terms of using the products. Okay, I'm going to move over to the next big area. And again, very much talking about nitrogen efficiency. And again, this is the low emission slurry spreading, referred to as LESS. And again, it's the #1 technology here, folks, in Ireland in terms of reducing ammonia in terms of agricultural emissions. Agriculture is responsible for 90% of emissions, and this is a key technology. And again, it's being adopted currently here in Ireland. I know across Europe, this technology, you're probably well familiar with this technology, but there's a big switch here in Ireland, especially over the last number of years. So again, maybe just to look at some of the areas in terms of reducing slurry nitrogen losses. So again, in terms of best practice, in terms of reducing ammonia volatilization, timing of application is critical. So again, we are encouraging our farmers to apply the slurry at the most efficient part of the growing season. And that tends to be, you know, as we speak in the springtime. There's a big nitrogen demand at this time of the year. We're heading into, you know, peak grass growth. And again, we can maximize the nitrogen efficiency because we have the conditions, you know, cool, damp, moist conditions. And our target there is to have 75% of the slurry applied by the end of April. Also, weather is a big factor. And again, probably becoming possibly a big challenge here in Ireland in terms of managing weather, especially as we speak. We're currently encountering a very cold, dry period. We've had showers of hailstones today. We've night frosts. But again, this is actually favorable from an ammonia emissions point of view, especially when we have the damp conditions. Now, in saying that, April has been a very dry month, a very harsh month, which would favor the loss of ammonia, especially using a splash plate spreader. So the low emissions slurry technology would be quite important in terms of reducing our emissions at this time of the year. Again, focusing back to some of the research, again, this work is done for a number of years here now in Ireland. It's done done up to 10 years ago by Dr. Stan Lawler at Johnstown Castle. And again, you can see the majority of ammonia loss happens in the first sort of 24 to 48 hours. So again, you can see here, this is the trailing shoe versus the splash plate. And again, the trials would show that we can reduce ammonia losses by up to 35%. So again, this is a key technology on the ammonia front and retaining more of that nitrogen in terms of grass production. So again, just to line up the three systems. So again, as I say, we're in a transition from moving from a splash plate to either a band spreader or a trailing shoe. In terms of nitrogen efficiency, again, the splash plate again is poor, like we're talking about 0.6 of a kilo of nitrogen recovered per cubic meter. As we move to the dribble bar, again, we're increasing efficiency up to 0.8, and then we move to the trailing shoe up to a kilo of nitrogen per cubic meter. So the trailing shoe is the most efficient as it's placing the slurry in a narrow band beneath the grass canopy, and that further protects or reduces the losses of nitrogen through volatilization. There's also other benefits to the trailing shoe, as you are aware. It does widen the window of application. There's more precise application. We can apply into heavier grass covers, reducing spoilage, quicker returns to grazing, and also we're protecting the soil as well, because we can go in, when soil conditions are in better condition or more favorable for the utilization of the nutrients in the slurry. Another, I suppose, just maybe to paint a picture here for you in terms of fertilizer replacement value. So again, I spoke about spring application. I've spoken about application method. So again, where we can wrap those two together, if we take an example here, say for first cut silage, typically we would be applying 33 cubic meters of cattle slurry per hectare. That's equivalent to 3,000 gallons per acre. If we go by splash plate in the summer, which is this bar here, versus trailing shoe in the springtime, there's a big efficiency in terms of nitrogen. We can increase the nitrogen recovery. We can go from, 10 kilos after our first cut silage to 33 kilos before or when we close up for that first cut silage. So there's a major efficiency there by changing the timing of application and also the method of application. So there's, again, a double dividend here, as I talk about. We can, retain another 23 kilos of nitrogen in the system to grow grass. That reduces chemical nitrogen onto the farm, and it also offers a saving as well in terms of the fertilizer bill. So like if you take our first cut silage, 33 kilos is approximately a third of the crop's nitrogen requirement, and we can supply that with a non-farm source of nitrogen as in cattle slurry. So in summary, Pat, I've probably gone through this a little fast, but in summary, again, we have two technologies. They're very sound. The research is done. They work in practice, and they have a major role in terms of us becoming more carbon efficient, reducing both ammonia emissions and nitrous oxide emissions. And that is protected urea. There's a double win-win there. It's also a cheaper source of nitrogen in terms of the cost of fertilizer N, and low emission slurry. So again, there is a force at the minute. There is a big uptake of low emission slurry application equipment on the ground. And again, you know, these two technologies combined, we can reduce our ammonia emissions by 80%. So like, you know, there's some like, I think 16 is megatons of ammonia to be abated, and these two technologies wrapped together can reduce our emissions, our ammonia emissions by 80%. Okay, so Pat, I'll leave it at that.
Thank you for that, Mark. If you just stay stop presenting your screen there, and if I could ask the other panelists, the other speakers to unmute themselves. I'm joined by Jocelyn, Sarah, and Paula for asking the questions. And Jocelyn, if I can put you on the spot, do you want to take one of the French questions first?
Yes, of course. Thank you, Pat. So I have a question. What about the objective of the project, which consists in reducing carbon footprint by 15%? Is it feasible in the 4 countries?
Might ask Donald to address that one.
I can help Donald as well, if you want.
Thank you, Jocelyn. I think maybe the question is almost going ahead, as Martina is probably going to address it in our next talk. But yeah, looking at the innovative farm program, it is looking very feasible that we can get to those levels of reduction with improvements in technical efficiency. So sorry to spoil your talk, Martina.
For me, at a European level, in the 4 countries, I think it is feasible, but it's still the dissemination of all the advice on the farm and the optimize practices are quite challenging because it's not done already. And maybe it's also one of the stage of the rocket we have to launch in order to have not a climate neutrality, but a climate to lower our carbon emission. So maybe there is 15 to 20% maybe in order to optimizing systems. I think on the innovative farmers in the 4 countries we're an average of 14%. Maybe it's a bit more in Ireland. But also with genetics, additives, or switching fertilizer, we have also other stage on our rockets to mobilize in order to lower our emission.
Okay, and there's a question there again, I suppose, to Donald, which asks, was the progress shown in Ireland that you showed between, I think, 2012 and 2019, was that more due to production efficiency or sequestration?
So it was largely due to improvements in productivity, was the main driver of that. I think mainly through, I suppose, earlier ages, finishing ages, and improvements, I suppose, on the breeding side in terms of number of calves per cow, all help to contribute to, I suppose, bring that number down gradually. So not so much on the carbon sequestration side so far, as we're kind of building up more knowledge on that process.
Okay, Paula, there's a question in Spanish there, if you want to unmute and let us know what it is.
Yes. Are the genetic rate related to smaller footprint already valued by Irish farmers and cleared countries, or are buyers continue to look only at traditional genetic parameters?
It's okay. I will answer that, Pat. Yeah.
Great, Andrew.
So certainly, Irish beef farmers are now much more conscious of the genetic indexes as opposed to the traditional approaches that the question has asked. The traditional approaches very much focus on the growth, the output, the muscle traits, the traits that we can visually see. Whereas if we think about what we look to do with the genetic information, it's about understanding the traits that we cannot easily see, such as, you know, milk, fertility, carbon efficiency, methane output. These are all the new traits, and certainly there's a growing confidence now in Ireland based on the very strong validation work undertaken by ICBF, by Teagasc, by the industry, that the indexes are now very definitely taking us in the right direction, and that is now starting to reflect into the purchasing decisions. made by Irish beef farmers.
Okay, Jocelyn, if you have one more, there's a number of questions in French there, if you want to come in with one of them again.
Yes, we have, so sorry, I'm following the emission measurements on animals. How do you characterize the animals that emit the least enteric methane?
So Jocelyn, I mean, what we see from the data is there's a very strong relationship between cow size and dry matter intake, which is also strongly related to methane yield or methane output. So, and if you think about that biologically, that makes sense. You know, smaller cows, smaller rumens, smaller methane output. But what is really important is that neither do we want too small a cow, because that cow also has to have enough of the growth genes, the milk genes, to have a good calf, you know, from a profitability and sustainability perspective. So it is very much about a balance. And the challenge or the problem that we had in Ireland was that we had focused too much on the growth genes, the output genes, and we've got big cows. So what we are trying to do is bring the size of these cows down a bit and increase the carbon efficiency, but not too small either. I mean, it is about a balance. That is so important.
One final question there before we move on. There's a question there, is most of your work, Andrew, done in relation to purebreds or in relation to crosses?
It's a combination. In Ireland, we're fortunate, perhaps unlike, you know, it's one of the challenges in France, for example, or in Europe generally, a lot of the evaluations are done within pure breeds. Whereas in Ireland, we have a lot of crossbreeding. So in our data, we combine both the pure bred data with the crossbreds, with the commercial cow data. And that allows us then to also compare across the different breeds. But what we do find in Ireland is, generally speaking, farmers have a preference for one or two breeds. And then what we want to really encourage them to do is when they purchase that bull or purchase that AI straw or purchase that female, that they're selecting the most carbon efficient animal or animals within that breed. And as a result of that, we get genetic improvement within all of the main breeds that are represented in Ireland.
Okay, thank you very much. We have a little bit of translation coming across there.
Esiste un elenco di migliori pratiche?
I would like to bring that first session to an end and thank all of our speakers for their excellent presentation. So the second session is more focused on farming advisory services. We'll begin with Martina Harrington, who's a beef specialist with Teagasc, and her talk will be on implementing low carbon practices on innovative Irish farms. So Martina, if you're ready to share.
Thanks, Pat. So can you see that?
Not quite seeing it yet, Martina.
Oh. Is it up there now? Share screen.
Yes, it's coming through now, Martina.
Okay.
Okay, that's great. Fire ahead.
Over there. Okay, thanks very much, Pat. I suppose what I want to go through today is our Innovate Farms and how they have worked in Ireland as regards the knowledge transfer of the, I suppose, the technologies for reducing the carbon footprint of beef per kilo. So I suppose if we look at the originally for the Irish Innovate Farms, they were created because of the low profitability, the issue with low profitability in the beef industry. So if we looked at it here from our profit monitor, 620 profit monitors that we did in Ireland in 2017, we were looking at a difference of €850 from a gross margin point of view on these farms. So I suppose when we looked at them originally, we were saying, right, okay, where is this coming from? And we could see that a lot of it related back to output on these farms. So it was basically that the output on the farm was very low per livestock unit and per hectare. So in 2008, we started the Better Farm Program in conjunction with the Irish Farmers Journal. So the objective of the Better Farm Program was to develop a roadmap for profitable beef production in Ireland through improving technical efficiencies within the farm gate. So what we wanted to show is that farmers could really improve the output for every animal on their farm while also keeping control of the cost. And the idea of that was to increase the profitability on the farm. So it ran for 3 phases, and in 2016, the live beef carbon came part of the program in that 3rd phase. And the objective of that was to reduce down the carbon footprint of beef by 15%. But when we were looking at this and looking at beef as a low profit industry, we wanted to make sure that when farmers were adopting these technologies, that the first technologies that they adopted were win-win. So they were going to increase the profitability while also reducing down the carbon footprint of these farms. So the focus was on grass, breeding, health, financial planning to improve profit and reduce the greenhouse gas on farms. So we set up a network of demonstration farms. So for a very small country, which Ireland is, there's a huge variation in rainfall and in temperature across Ireland. So if you look here along the west coast, you could have 2,500 to 3,500 mils of rain per year. And if you move across over to the east and southeast, you could have half or a quarter of that. So the technologies that were going to be introduced in this part of the country wouldn't be applicable to farms up here. So what we were learning through previous programs was that farmers up here would not adopt the technologies that were demonstrated on farms down here. So we picked farms right across the country that were representative of the farm type and the land type and the system in their region. So each farmer in Mayo could learn from Richard Jennings, while each farmer down here in Cork could learn from Ger, who's going to be on later, and over here in Kildare could learn from the likes of Ricky Milligan. So those farmers then came on board, but they had to be open to taking on these new technologies, some of which we've covered so far. So these farmers got a very intensive advisory service. They had 1 advisor per 10 farmers, so it was exceptionally intensive. There was 12 farm visits per year, so these farmers called down, or these advisors called down once a month to the farm. They soil sampled the farm, did a soil fertility plan. They looked at the infrastructure on the farm as regards water and paddocks. They looked at putting in measuring. So all of these farms were grass measuring to increase the production of grass, which would increase or reduce costs while also improving animal performance. They looked at grass measuring, that's our pasture-based Ireland. And we also looked at weighing the cattle. So we incorporated all of these things onto the farm, but we wanted to make sure that that was resulting in better weight gains of these animals. And like what Andrew said, reducing the age at slaughter. So we wanted to see the age coming down, so that would reduce down the carbon footprint of each of these animals. So we also concentrated on nutrition, a breeding plan like Andrew covered there, and health plans on these farms, all with the aim of increasing the animal output per livestock unit and per hectare on the farm. But as we know, farmers learn from other farmers. So to get this information, we went down and we worked very, very closely with the farms, but then we also wanted to get that information out to other farmers in the country. So we looked at how we were going to do that, and it was done through farm walks, like you can see here, discussion groups coming in onto these farms, and then also by putting out 2 pages in a weekly Irish Farmers Journal, which told what each farmer was doing, how they were doing it, and why they were doing it. So we were building a profile and a relationship with these farmers, these demonstration farmers. So if we go back and we look at what we were talking about, why is it a win-win, or what type of win-win strategies did we put in on these farms? And we look at breeding, because I know Ger and Ricky are going to talk about that, and Andrew has already covered it under the BDGP. When we went in and we looked on these farms and we said, well, how can we improve performance? And this is work carried out by Paul Crossan in Grange. And we looked at improving the calves per cow per year. So if we can improve our calves per cow per year from 0.85 to 0.95, we can improve the profitability of that system by €87 net margin for every cow that's on that farm. if we can reduce down the age at first calf, and so pull back, a national average in Ireland is 32 months. If we can pull that back down to 24 months, there's a €50 difference in net margin per cow. And then your 6-week calving rate, if we can increase that from 55 to 80%, that's another €28. So purely by the breeding efficiencies of these cows, the more fertile cows, producing a calf per cow per year, getting weight for age that they're able to calve down at 2 years of age, we can already increase the performance or the financial performance on this farm. And then if we come and we look at the progeny of these cows, if we can increase their average daily gain, so if we have a better quality animal on the ground that is being managed better from a grassland point of view, from a nutrition point of view, and from a health point of view, and if we can increase their average daily gain from 1.05 to 1.25, you're looking at €86 per cow. And if we can reduce down what meal feeding, so if we can get better weight for age in these animals off grass, and we can reduce down the meal feeding, you're looking at another €52. So from the national average to where a lot of the Innovate farms ended up, there's €303 of a difference. So there's a significant financial gain to be made by improving the technical performance on these farms. So that's the one side of it. And then if we look at from the carbon footprint side of things, in Ireland currently, well, thereabouts, we're looking at, for every 10 calves produced on a farm, we carry 12 cows. So for those 12 cows are producing 85 tons of carbon. So what we're looking at there is that there's an extra 2 cows on the farm that aren't producing a calf. So if we can reduce that down, or if we can increase the calves per cow per year. So for every 10 calves, if we can carry 1 less cow and make that 11 cows, that's 80 tons of carbon that's being produced. So we're looking at a reduction of 6%. So for every reduction of a cow per 10 calves being produced on a farm, there's a reduction in the carbon footprint of 6%. So that's what we're looking at as regards win-wins on these farms. So if we look at that, we're looking at from a breeding side of things, you know, producing your calf per cow per year, and the other low carbon farming techniques that we put in on these farms was your health, your grass, reducing your age at slaughter that Andrew already spoke about, calving your heifers at 2 years of age, having a longer grazing season. So when farmers are able to get out earlier in the season, they're able to stay out longer. You're looking at a reduced length of time in the shed and reducing your carbon footprint. Incorporation of clover onto some of these farms, improved soil for fertility that Mark talked about, that you're able to reduce down the amount of nitrogen that you're putting on these farms and still grow the same amount of grass. The use of protected urea and the use of low emission slurry spreading. So all of these technologies were I suppose pioneered on these farms, on these Innovate farms. And as a result, there was a 12% reduction in the carbon footprint, the gross carbon footprint and the net carbon footprint of these farms from 2016 to 2019. So it was a huge improvement. And I suppose this is one of the big cows that Andrew was talking about earlier. But Ger and Ricky will go through what they implemented on their farms and how it reduced the carbon footprint on each of their farms. So thank you.
Thanks very much, Martina. That was excellent and really clear. So thanks for that. So we move on now, and our next speaker is Germax Sweeney, and Ger is a farmer from Mill Street in County Cork, I think. Ger will be discussing a given talk presented or called A Munster Beef Farmer's Guide to Increasing Carbon Efficiency. I think we're going to just challenge the technology a little bit further here and begin this, Martina, I think with a video, if I'm correct on that.
My name is Germax Sweeney. I'm farming here with my wife Karen and my daughter Ella. We farm here in about 25 hectares of land. My farming system here is Suctor to beef, and I finish the bulls, male progeny under 16 months, and the female, the heifers, approximately 24 months there. We run here 35 sucker cow herd here, and I breed my own replacements, and I use 100% AI on the farm, and this gives me huge options when I am doing my replacements, and also my terminal bulls. Like heat detection is a very important part of this process after installing, and the intelligence systems for picking up artificial or heat on cows, and it's called Sense Hub by Allflex, and this tells me the optimum time for inseminating cows when they're coming in heat. It picks up on silent heats, and it just gives me an extra bit of confidence when I'm in my cows. All cattle are weighed during the year. This is very important to know that they're doing their average daily weight gain, and heifers are mostly finished off grass-based system here on the farm over the summer months and into autumn. Cattle get very little ration until they come into the shed. Weanings, they start off in approximately 3 or 4 kgs, especially the bulls, and these will be ramped up to ad-lib feeding before they are slaughtered off farm. Heifers would be on eat less ration. Silage is tested here at the end of the year before the cattle come in, and to know exactly what their D&D the silage is, and cattle are fed accordingly. We soil sample the farm here regularly. We lime and we fertilise according to these. Since 2018, the soil fertility in the farm here has increased by 25%. Measure grass here with a plate meter every week. I do about 40 measurements a year, and my dry matter tonnage has increased by 2.5 tons since 2017. I do incorporate clover into my reseeds. I do use protected urea. We have a good infrastructure accessing the farm. My farm is split in two by a main road. Land drainage is important in a section of the farm which is wet, and since doing it in 2018, it has brought a lot of ground back in which was not accessible. Making life easier for me, being able to get more outputs out of the farm, using fertilizers at the correct time and using slurry at the correct time, maximizing usage of nutrients on the farm, and using the correct nutrients for the correct soil type. Liming has been a huge part of the farm as well, getting that correct. Basically getting more outputs at a younger age off the farm. Cows are more efficient, cows are healthier, and the breeding has improved. So it's a continuous process, but the improvements have been huge. The cattle leaving the farm here are at a reduced age at slaughter, and also I have increased my carcass weights, and that's what the good thing about this is reducing my carbon footprint per kg of beef sold off the farm.
Thanks very much, Ger. Your presentation is coming up there now. If you ever have to give up the farming, there's a role for in acting for you, and that little daughter of yours as well.
Good evening, everybody. My name is Germax Sweeney. I'm farming here in the south of Ireland. I farm 25 hectares, and the land is divided into 4 blocks. My main farming system here is suckling to beef. It's predominantly grass-based. I have a 35 spring calving suckler herd. Bulls and heifers are finished off farm, and I breed my own replacements using 100% artificial insemination. I farm at a pretty high level here. My highest point is over 900 feet above sea level, and I do get a lot of rainfall here as well, and we're well above average. The average air temperature has risen by nearly 1 degree Celsius in the last 5 years. Since joining the program in 2017, my focus has been on breeding management. I've improved fertility in cows. I've increased the weaning weight, their average daily weight gain. I've reduced the age at slaughter, and I've increased the carcass weights. I've also reduced the size of my cow. On Grassland Management, I have the farm divided into paddocks. I measure these grass on a weekly basis, and I am constantly improving soil fertility and increasing my weight gain from grass. My weaning performance has seen improvement since 2017. My heifers have gained an extra 19% per day, and my bulls have gained an extra 8% per day. And this means that's a huge difference when finishing stock at a younger age. My finishing performance has seen improvement. My slaughter age of my heifers and my bulls are slaughtered a month younger, and the carcass weight of the bulls has increased by 25 kgs and the heifers by 18 kgs. Increasing these weight gains and finishing performance is down to mainly genetics and improving grassland management. My breeding performance. I am using 100% artificial insemination on the farm. I am using top AI bulls for both replacement and terminal trials. I use an ICBF Eurostar index to source these top AI bulls. This gives me excellent, efficient cows for breeding. I also cull unproductive cows every year from the farm. I use heat detection from my artificial insemination. I was using a vasectomized bull, but now I have changed to a more technology all-flex sense hub heat detection system. There is a tag on the ear of each cow, and this gives me real-time feedback on heat and health detection. I use whiteboards on the farm, and this gives me information on calving, bulling, breeding dates, and vaccinations every time I walk past it. On grassland management, my soil fertility has improved year on year. Soil samples were taken in 2018, and I implement a fertilizer plan which has recommendations for pH, phosphorus, and potassium use. I've improved the soil fertility of the farm by 25%. This is work in progress. I have improved the infrastructure on the farm as well. This is very important with adverse weather conditions we are getting. It's very important to get animals on and off paddocks if weather does not suit. I've increased the number of paddocks from 12 to 37, and I've added more water trucks. I have improved access via roadways and gates. I measure grass weekly using Pasture-Based Ireland. This helps me to make better grass decisions. I can take out paddocks for silage if needed, and I use the grass wedge to manage this grass better. Since 2017, I've increased grass production by 2 tons of dry matter per hectare. I reseed the worst 2 to 3 paddocks every year. I am using top quality grass seeds, and I am incorporating clover into the reseeds. I am using protected urea as my main nitrogen source on the farm. Overall performance. I've increased live weight gain of the beef stock. I'm reduction of the finishing age, and I've increased the carcass weight. I am reducing methane and carbon footprint per kg of beef, getting more efficient use out of farm inputs, including feed, organic, and chemical manure. Below is a table which shows the improvements that have happened on the farm since 2017. Thank you for listening to me, and I hand you now back to Pat.
Thank you very much for that. And just to remind you that if you have any questions for Ger, if you put them in the question and answer. Okay, we'll move on from a Munster farmer to a Leinster farmer, and maybe rugby is not the only place where people compete with each other. So we're moving to Ricky Milligan, and Ricky is an innovative beef farmer, and he will be talking to us about climate smart beef farming in Leinster. And first, again, I think we have a video.
I'm Graham Waters, and I'm a dry stock advisor in Naas, County Kildare. I'm here today to introduce my client, Ricky Milligan, and how he increased his profitability and beef output while reducing his greenhouse gas emissions through the Innovative Farm Program. Ricky did this by improving his calving performance, his soil fertility and his grassland management.
Hello, my name's Ricky Milligan and I'm farming in Robertstown, County Kildare, Ireland. I farm in partnership with my father Henry. We farm 2 blocks of land totaling 64 hectares, of which 50 hectares is in grass and the balance in tillage. We run a spring calving suckler herd of 40 cows. We have a dairy calf to beef enterprise of between 40 and 50 calves per annum.
I joined the Innovate Farm Program in 2017. I saw it as an opportunity to increase profitability, improve farm efficiency, cut farm costs and reduce greenhouse gas emissions. The opportunity to work with 2 technical advisors on a regular basis was very important, as we could work on grassland management, soil fertility and animal performance. At the beginning of the program, we examined key performance indicators on the farm that could be improved quickly. Calving interval has been reduced through focus on heat detection, improved body condition scoring and culling of poor performing cows. Calves per cow per year has increased, meaning more calves over the cow's lifetime. All heifers now calve down at 24 months of age. Grass growth rate on the farm is measured weekly with a plate meter. Grass utilisation is higher and there is always a quality sward in front of the animals, leading to consistent and higher daily live weight gains. There are 72 paddocks on the farm. This allows a greater control on what the animals eat. Surplus bales are taken out when grass growth is high. Silage is tested to determine quality. Improved grassland management leaves high quality silage, less meal feeding and reduced costs. Regular soil sampling is carried out, focusing on optimum soil indexes. A low emission slurry spreading trailing shoe is used on the farm. All slurry is spread on silage grounds or fields with low soil indexes. Stocking rate has increased, leaving higher output of beef per hectare. Through increased live weight gain and early maturing breeds, slaughter age has been reduced. The Innovate program has improved technical efficiency, beef output and profitability. I have seen improved soil fertility, grass growth and utilisation. I have reduced fertilizer costs and feed costs. Overall, greenhouse gas emissions have decreased.
Overall, Ricky has increased his profitability and his beef output. By following the technical advice, Ricky was able to reduce his greenhouse gas emissions by 18%.
Okay, Ricky, if you can unmute and if we can have the presentation. Right. We potentially have a, oh no, it's coming. Thanks very much.
Yeah, we're getting there, Pat, yeah?
Yeah, just beginning to get worried.
Okay, thanks, Pat. We're ready to go now.
Okay, fire ahead, Ricky. Thanks.
Okay, good evening, everyone. My name is Ricky Milligan, and I'm farming near Naas, County Kildare, just about 40 minutes west of Dublin. Been farming the family farm in partnership with my father Henry here since 2011. The system is a mixed farm. We have a spring calving suckler herd, a dairy calf to beef enterprise, and a small tillage enterprise. We also have a block of forestry grown and managed under the Afforestation Grant and Premium Scheme. We're involved in most relevant farm schemes, including the BDGP, as Andrew alluded to earlier on, BPS and the GLOS Environmental Scheme. We are members of the Board BA Quality Assurance Scheme and also members of the Irish Hereford Prime Producer Group, and we were delighted to receive the Producer Group's Farmer of the Year award in 2020 for consistently supplying cattle of qualifying grades. We are farming 64 hectares of land, medium loam throughout. For the most part, the ground is dry and trafficable from early spring through to early winter. Currently, there is 50 hectares of grass and the balance is in tillage. We are fragmented, 2 blocks 3 miles apart, with busy roads splitting each of the blocks. Our suckler herd is calving from early February to late March, early days of April. Most cows breeding goes back to when the farm was in dairy, with Limousin and Simmental genetics initially giving way to Hereford genetics for the last number of years. Mainly Hereford cross calves are sourced for the dairy calf to beef enterprise. We were pleased to join the Innovate Farm program in 2017, giving us an opportunity to focus on cost cutting, technical efficiency and profitability, which in turn has had a positive effect on greenhouse gas emissions. We work closely with the program advisors, as well as our regular farm advisor. The advisory visits were monthly and focused on technical advice relevant to the time of year and on data recording. Typically, an advisory call would involve a walk around the farm, focus on management topics such as grass growth, fertilizer strategy, silage quality, nutrition, and herd health. With regular contact, the advisors were always up to speed with what was happening on the ground, so the visits were focused and beneficial. As shown in the table, all the key performance indicators went in a positive direction, and there is still scope to improve further over the next number of years. We would have been looking for a higher gross margin by the end of 2019. However, the challenging physical and trading conditions over the course of the program were difficult, but they were mitigated to a certain extent by the program. Soil fertility is an ongoing area of focus on the farm. As part of the program, all fields were sampled at the beginning and at the end, and regular sampling is continued. The aim is to maintain pH of around 6.2. The farm is in a high molybdenum area, and we do see copper deficiency in cattle. Steps are being taken to maintain P&K index at 3. Slurry and farmyard manure is targeted at appropriate fields, depending on soil results. Balances then made up of appropriate bagged manure. Grassland management has been improved as part of the program. Really, this has been the cornerstone of making our system work. Fields are walked and measured regularly, and decisions are taken from there. The aim is to always provide a quality sward to all cattle, make good quality first cut silage from specifically closed paddocks and surplus grass, and to extend the grazing season as long as conditions allow. Additionally, we grow brassica catch crops. However, this can be challenging to operate successfully. We went into the GLOS environment scheme under the low emission slurry spreading measure. It was a mandatory action for us. However, I am completely converted. More nutrients retained, less inconvenience on neighbours, less grass contamination, and less emissions. It is important that the slurry is well agitated, not too thick, for the systems to work. There was no problem finding a contractor with the right equipment, and I favoured the trailing shoe over a dribble bar. Prior to joining the program, we moved a lot of our breeding towards Hereford genetics. Primarily, this was to enable us to finish cattle before the second winter without getting into needing more winter accommodation, high levels of concentrate feeding, etc. This was an area we then concentrated on through the program and have been able to finish cattle targeting the specifications required by the Hereford Prime scheme, anywhere from 17 to 24 months from grass with very low levels of meal feeding. It is a mindset we are now in, the reward for which is reduced costs and reduced emissions. As part of the Innovate program, we have improved technical efficiency, improved beef output, and profitability. We've achieved a substantial reduction in ammonia emissions. We've reduced our artificial fertilizer inputs. We've increased grass growth and utilization. Overall, we now have a more efficient herd of cows and a more efficient farm. The biggest challenges during the program would be weather conditions in 2018, from a very wet spring into an exceptionally dry and drought situation throughout the summer. Going forward, we are now in organic conversion on the farm. This will, by default, will further reduce our artificial inputs. We'll be focusing further on the low emission slurry spreading and also on how we optimize the use of our farmyard manure. We're incorporating white clover into our existing grass swords, and we're also starting to move towards multi-species swords. We will also take more notice of the environmental impact of our farming activities, continue to reduce greenhouse gases, and focus on soil health as a means to sequester carbon. Thank you very much for your time. Back to you, Pat.
Thanks very much, Ricky. That was really informative. And again, if anybody has any questions for Ricky or Ger, would you please put them in the question and answer again in your own language. Our final speaker tonight is Tom O'Dwyer, and he's head of the Signpost Program in Teagasc, and he'll be describing the Signpost farms pointing the way to sustainable agriculture. So Tom, yeah, we have your presentation if you just want to go into presentation mode.
Good evening, everybody. I'm afraid my video is disabled, so Pat, if you can correct that, I can turn on my video when, yeah, okay. Okay, thank you. Okay, and slideshow. Okay, so you should be seeing my first slide. So thanks to the organizers of this evening's webinar for the invitation to speak. And I was quite taken by the presentations from the two farmers, from Ger and Ricky, given that demonstration farmers are a key part of the Signpost program. So the Signpost program is a new initiative from Teagasc, and the purpose of this new initiative is to lead all Irish farmers towards more sustainable farming systems, and principally to, I suppose, replicate what Ger and Ricky have achieved in terms of reducing emissions from agriculture, while also, I suppose, paying attention to other environmental issues in relation to water quality and biodiversity. So the title of my presentation this evening is Signpost Farms, Pointing the Way to Sustainable Agriculture. As I said, my name is Tom O'Dwyer. What I'll cover during my presentation this evening, a very brief introduction, then an overview of the Signpost program, before moving on to talking about the key role that demonstration farmers will play in pointing the way forward towards more sustainable farming systems. And I suppose, you know, what I want to highlight in my presentation, I suppose, really is the importance of farmers like Ricky and Ger and how they can influence other farmers. I think I heard Martina commenting earlier about farmers learn from other farmers, and that really is what underpins the Signpost program. There will also be then an advisory campaign as part of the program. I'll talk briefly about that and then to conclude with the summary. So far, what has Teagasc done? Some of this has already been covered, but you know, research at Teagasc has identified a range of technologies which, once applied and adopted by farmers, can reduce emissions. And I describe this as our toolbox of tools. So an advisor working with a farmer can identify the technologies that can be applied on the farm. But we now need to enable farmers to adopt their farming practices at pace and scale. So we need to upskill our advisors so that they can work with farmers like Ricky and Ger to encourage, enable, empower farmers to make the switches to protected urea, make the switches to low emission slurry spreading, make the switches to including more clover, make the switches to organic farming as Ricky has just described. And also in Teagasc, then we will continue with new research to identify new technologies which can be applied in the future. I think it's important to acknowledge at the outset of the presentation, though, that farmers and farming is key to protecting our environment. So farming has shaped the environment that we have today. But there is also now an increased focus on the environmental impact of farming activities. But farmers themselves are uniquely placed to be part of the solution, because without farmers, you know, we won't achieve the changes that we want to achieve. So farmers can act as custodians of the land. And I think it's very important that we recognize that and recognize the key role that farmers will play in providing solutions. The key role in protecting soils, managing hedgerows, protecting semi-natural habitats and water quality. And the achievement of net zero in terms of greenhouse gas emissions, in my opinion, is not possible without the conservation and enhancement of a farm's carbon stock. So Teagasc is setting out on a research program to establish the amount of carbon that's stored in our soils and hedgerows. And this is influenced by management practices, but also soil type and so on. But we have to have a better understanding of that and to be able to advise farmers in the future as to how they can better manage soils and hedgerows to store even more carbon. So leading then on to the Signpost Program itself. So the Signpost Program is a national campaign which is just about to be launched by Teagasc. The purpose of the campaign is to lead climate action and to achieve early progress in reducing greenhouse gas emissions. There are 3 elements to the program. The first will be a network of 100 signpost demonstration farms. Farmers like Ger and Ricky who will act as demonstration farmers. So they will receive intensive advisory support as outlined by the 2 farmers and also by Martina to equip them and enable them to make the changes on their farms that have been identified by research. And while we are supporting those farmers, we will also be taking measurements and recording data so that we can tell the story of what has happened on those farms. And those farms then in turn will be central to the wider Signpost advisory campaign. So we will use and work with the farmers so they can become part of the message and take part in delivering the message. So it isn't just Martina or other advisors who are telling farmers what to do, but it's farmers sharing their experiences with other farmers. And the other element of the Signpost Program then is further research through that research program that I've just referred to, looking at carbon sequestration. And a key objective of the program is to ensure that all of the Irish agricultural industry is aligned around the program. So what are our objectives then? For the signpost farms or demonstration farms, it's to showcase the science-based technologies which can reduce agricultural emissions, and to act as hubs for the Signpost Advisory Campaign, and to create a national network of farms where carbon sequestration in grassland and hedgerows can be examined. And the purpose of the advisory campaign then is to mobilize all advisors, whether they're our own advisors or private advisors or industry advisors, to engage with all farmers using a combination of channels and climate actions. Because really what we want is we want consistent and messaging from all the actors that are engaging with farmers. Because we could do a very good job within Teagasc, but then if we have other actors who are engaging with the farmers who are not recommending the practices which can reduce emissions, that can undo the good work which we in Teagasc could be doing. So this slide just acknowledges the key role that demonstration farmers play, both in firstly the application of scientific findings and new technologies, as evidenced by the previous presentations. So they adopted protected urea. The farmers adopted low emission slurry spreading. They adopted and they changed their calving pattern, and they improved their reduced their age at slaughter. So these are and improved their grassland management. So these are the technologies that can be adopted, and the previous two speakers have demonstrated what they have changed over the previous number of years. But the more important piece, perhaps, for ensuring that change happens at the wider level amongst all farmers is the role that the demonstration farmer can play in spreading best practices and innovative farming approaches. So whether it is through taking part in webinars like this evening, or featuring in articles, or hosting farm events, or participating in a discussion group or a discussion circle, all these activities help to spread the message. So that'll be a key role for the demonstration farmers in the Signpost program. So for our demonstration farmers, what will it mean? we want Signpost farmers to be champions for climate action. So, to embrace and integrate science-based solutions, to farm smarter, to use fewer inputs, to use bio-based solutions to displace fossil fuels, to work in partnership with their farm support team. So the various advisors that are visiting the farm, that the farmer works with them, and I suppose takes the best bits of the various messages and applies them on their farm. We want our demonstration farmers to be innovative, to try things, to be, I suppose, to be brave and having listened to the advice, to make a decision and put into action on their farm. And then I suppose, and the most important thing for me is that having done that, that they're willing to share the possible, to shape positive change amongst more farmers. We want the Signpost farmers to be the change that other farmers can see, to point the way to a better climate. We want to use what's referred to as a living lab approach, where the Signpost farmer tries things out on their farm. We who are running the program learn from that, and perhaps we adjust our messages, our messaging for other farmers. And we also want to work with farmers using a co-design approach to identify tailored solutions that are suitable to individual farmers. It's not a case of one size fits all. We have to try and figure out what works for individual demonstration farmers before then taking that message to other farmers. For sure, there are certain technologies that, that we can say, if you can improve reduce your age at slaughter, that helps in reducing greenhouse gas emissions. But how does an individual farmer reduce age at slaughter? The solution might be slightly different for different individual farms. And as advisors, I think we have to be very, very cognizant of that and try and tailor the solution for the farm. In terms of the wider advisory campaign then, and you have a photograph here of one of our advisors engaging with a group of farmers, we want the Signpost farmers to be central to the wider advisory campaign. We want to make sure that our advisors make sustainability a primary focus for their work programs. And we want to provide tailored advice through a farm sustainability plan so that we can treat each farm and each farmer as individual, and we can provide advice best suited to that individual farmer. And we then want to use a blended approach of both traditional and digital communications to engage with farmers. And we want to work with partners. We can't do this on our own. So we're taking a collaborative approach to the Signpost program. We want to work with milk and meat processors. And in fact, they want to work with us. And we've got a very good response to our proposals for the Signpost program. So we expect that we'll have a very strong partnership approach to delivery of the program. So Chairperson, in summary then, the key role of demonstration farms in bringing about change is recognized through the design of the Signpost program. We will create a network of Signpost farmers, and they then in turn will be central to the new Teagasc Signpost program. Once again, thanks for the invitation to present about the Signpost program this evening. My contact details are on screen if anybody wants to contact me after the event, and quite happy to take part in questions and answers following this presentation. Thank you.
Okay, Tom, thank you very much for an excellent presentation. If our other panelists could join us, and Jocelyn, Sarah, and Paula. Tom, I suppose a quick question to start with. How important is the movement towards sustainability, and I suppose in particular lower greenhouse gas emissions? How important is it for the marketing of our produce?
Well, I suppose I'll preface my answer by saying I work for Teagasc as an advisory service, so any insights that we have on the marketplace are through our relationships with our partner organizations. So, from listening to our partner organizations, it has become quite apparent to me, Pat, that the marketplace, be that customers who are buying, say, the raw material that we produce, beef in this case, or indeed the consumers, the people who are going into the supermarkets and buying the products on the supermarket shelves. The feedback from both customers and consumers is is all about increasing an increasing request or ask around sustainability, and not only that we highlight the sustainability of Irish beef, but that we can verify our claims, that we can actually document that there is data to back up the claims that we were making in our promotional and marketing materials. So from in summary, Pat, from talking to our partner organizations, it is quite clear to me that there are increasing demands being made on our processors, on our meat processors in the area of sustainability.
Okay, I'll move to Jocelyn, if that's okay. A number of French questions, Jocelyn, if you want to give us one or two of them.
Yes. So it was really linked with your last question, Pat. It was, in fact, how do you plan to promote the carbon footprint reduction efforts that are carried out in Ireland, and especially on your export products? I think, is there some labeling question in Ireland or something like this?
Yeah, so I might just start and others can come in, I suppose. So I suppose first and foremost for me is that we have to measure what's happening on farms. So Board BIA is the marketing organization who's responsible for marketing Irish beef, and it measures the sustainability of production every 18 months on, I think, about 55,000 beef and lamb farms. So there's a fantastic database of information there, and Board BIA use that information to generate statistics, performance statistics, I guess, and they can use that in marketing campaigns. Ourselves within Teagasc, we have an annual survey which is representative of beef production called the National Farm Survey. And as part of the National Farm Survey, Teagasc generates an annual sustainability report. And as part of that sustainability report, we produce a figure for the carbon footprint of Irish beef. And I know Donal is more familiar with that than I am. So if Donal wants to comment, perhaps he can add to that.
Yeah, no, I think, Tom, that's fair to say. Maybe it's not, just to be crystal clear about it, the footprint in the National Farm Survey would not be the full footprint for beef, although what we have found in our beef production is that the vast majority of it is accounted for by what's happening on the farms through the actual methane from the animals. That's the only thing I'd add in.
Okay, there's a question there for Ricky about the main opportunities and the challenges associated with moving towards organic production.
I think you have him turned off over there.
I think you have me turned off there, Pat.
No, we can hear you there, Rick.
All right, yeah.
Camera.
I just can't start my video there, that's all.
Oh, okay. Oh, just don't worry about the video.
Yeah. So the main, what do I see as the main opportunity, or why have I gone organic? I think the main opportunity for me is that there's an opportunity to reduce costs further, and also to increase the value of our output, albeit after the 2-year conversion period. And I suppose it's a bit of a sudden step probably, but the department opening up the organic farming scheme to encourage people to go in is a short window, and there's no guarantee that will there's no guarantee of entry, but there's also no guarantee that will open again next year, so far as I can see. So that's that. That I have also been encouraged to go in because of the scheme as well.
And is the tillage side of the farm going in?
Yeah, it's everything, in for a penny, in for a pound. The enterprise that will lose out will be the dairy calf to beef. I'll keep the sucklers, and I will increase the tillage so a little bit as well, to keep the and use rotational grasslays with the animals as a fertility building, as the way to build fertility for tillage.
Okay, thanks for that. Jocelyn, some more questions from our French colleagues?
Yes, I had a question from a French to Ger, sorry.
Sure, yeah.
Which breed or crossings are you using with your 100% artificial insemination?
You're on silent, or you're on mute, Ger.
Okay, can you hear me? Okay, my cows are predominantly Simmental and Limousin crosses, and I cross back Charolais cows or Charolais bull for terminal traits, and I use Limousin and Simmentals for maternal traits. They'd be the two prominent bulls I use. I use an easier calving Solaire bull for my heifers, which will be in their the first year, but predominantly Limousin and Charolais.
Okay, thank you for that. Have you any further questions, Jocelyn?
I had a question about including carbon mitigation programs into eco scheme for Ireland, into the CAP eco scheme. Is it something you have work on this type of eco scheme?
Yeah, I suppose I could probably take that. In relation to eco schemes, we don't know yet exactly the formation of the eco schemes. A lot of thought being given to it, but certainly a lot of consideration being given to reduce carbon, I suppose, practices at farm level, because they fit well with eco scheme. They may be win-win or low cost to the farmer, as opposed to some of the measures in an agri-environmental scheme, which are more cost associated. So I think there's a lot of effort going into trying to ensure that lowering our footprint and lowering our emissions will be key elements in the eco schemes. Okay, I think we've most of the questions dealt with. I suppose I'd like to take the opportunity to thank first our audience for coming on here tonight.
Maybe Pat, sorry, Pat, do you want to give
in English?
in Italy?
Oh, sorry. Yes, sorry, Paula.
I go with the question. Are the efforts made by the farmers recognized by the administration are also taken into account in national calculation of emissions?
Sorry, Donald, do you want to?
So I think what we've done in the Carbon Life project, it is indirectly reflected in the inventories through less fertilizer use, more nitrogen efficiency. Animals, you've less older animals in the inventory, but at the moment there's no direct scheme to pay or compensate farmers for mitigate emissions on their farm. But I think maybe Jocelyn might like to comment, or maybe Pat would say at the end that I think there's plans to do something like that, to have a monitoring, reporting and verification scheme to give credits to farmers where there are to mitigate the risk in reducing carbon emissions on their farms in the future. So maybe that's a bit of a long-winded answer, but that's kind of where we're at with it, I think.
I suppose, Donald, there's a lot of work to go on there to try and give credit to farmers. We're a little bit away from it probably nationally at this point, I suppose particularly on the sequestration side, which is a question we had earlier. So I think a lot of people putting a lot of effort into the quantification of the sequestration and the carbon capture. And then once that's done, there is a possibility of starting to give credit for it. Jocelyn, do you want to comment?
Yes, regarding rewarding farmers for their effort, of course there is public subsidies possible, like eco scheme, or I don't know, maybe agri-environmental measures. Sorry, There is also a consumer's premium. We have to work on it. We know that we have to work on it, and also private finance, like the carbon credits, and maybe we can make the link with the carbon farming project we are all parts of, especially Teagasc and IDEL. So and also the Asoprovac and the CREA. So we hope that we can capitalize on this. And that's my answer.
Okay, thank you very much, Jocelyn. Okay, I think that's we've hit time to go, and again, I'd just like to really thank the speakers. First of all, for excellent presentations. Secondly, I suppose keeping to time, and thirdly, I think keeping to a speed that has allowed the interpreters to do their job effectively. And I would like to really thank them for making this webinar possible for all of our attendees. For you, the attendees, I know it's not a replacement for visiting the beautiful area around Ger and Ricky's farms, which would have been really nice to hit Cork and Kildare instead of being stuck in watching a computer screen, but maybe we'll get back to that in the not too distant future. So listen, a big thank you for attending tonight, and as I say, hopefully in the future opportunities will arise for farmers to share internationally, which is one of the key objectives of this project. Finally, I'd like to thank Jocelyn and Donald O'Brien for organising the conference. I think they've put a huge amount of work into it, and I think it's gone very well. We've avoided major technical hitches, which is always a fear when you're starting this. Narrowly, it may be said, which people may not realise, but we've avoided them anyway. So listen, thank you again for attending, and hopefully we'll meet again in the future face to face, and have an opportunity to share on farm experiences. Thank you.
On behalf of the French delegation, I really want to thank also, sorry, but Jer and Ricky, and also Pat, and especially also Donald and Martina, because I didn't make so much things. It's really Martina and Donald that organize this event. So really thanks to both.